Hello friends, today I'm going to solve LeetCode problem number 926, flip string to monotone increasing. So what's a monotone increasing string? Well, in a binary string, a monotone increasing string consists of zeros followed by ones. So it could only have zeros or it could only have ones. If it has both of them, then zeros should be followed by one. And now what are we given is a string as a binary string, and we need to change it to a monotone increasing string. And the way we need to change it is by making minimum number of flips. That is, we could either change 0 to 1 or 1 to 0, but while we are doing that, we need it to be the minimum. Now, how we could solve this problem? Let's just take this example problem and let's see here. So this is the string here given to us. Now, in order for this to be monotone increasing, there are three criteria, like three things that we could do. Either all of that should be equals to 0, that's one thing, or we convert all of them to 1, that is all of them are 1, or what we could do is we convert only ones and the last digit to 1, so that's still monotone increasing, right? So what we did is we converted these to zeros, so there are two changes here, right? Two. Or what we did is we converted the zeros and this 0 to 1, so there are how many changes? Three changes, right? So here we made three changes, three flips. Or what we did is we just changed this number, so we just changed this digit here, and the number of flips that we made is 1, right? So this is the minimum number of flip to achieve a monotone increasing string, hence this will be our answer in this case. So what are the possible things that we actually did? Well, basically, if we just look, we don't have to make this change. Why? Because for monotone increasing, if we have not encountered 1, as long as it's 0, it's monotone increasing. So if we encounter a 1, then it's still monotone increasing, right? In this case, if you just look at this example, so it is still monotonically increasing. Now we encounter another 1 and it's still monotonically increasing. Now we have a 0 after a 1. So since we have a 0 after a 1, this is not monotonically increasing, because after a 1 it should be 1, right? Or anything before 0 should be equals to 0. So the flips that we will actually be making is only these two flips, only these two. So we are actually flipping only these two, because that would give us a monotonically increasing result, or we are just flipping this 0, just this one digit, and that would give us this monotonically increasing string. Now we need to look at which is the least one. So what we do is we actually keep track of all the numbers. So what we are doing, we are changing all the ones before zeros, right? In this case, to obtain this case, so we keep track of the number of ones before we encounter a 0 after 1, and then we try to make the change, and then the change that we make, we then compare that change with by just changing the last 0 digit to 1. So since the 0 digit conversion takes less number of flips, so since we choose this as our answer. Now let's try to code our answer. So what we need is we need to store our result in the result array, I mean result integer, so it's an integer, and we also need the number, right, the number to store the number of ones. So let n be the number of ones, it's initially equals to 0, and then for each of the character in as. So what we do is we check if the string, if the character is equals to 0, then we if the character is 0, so if we have not encountered any one so far, then the value of n would be equals to 0. So the number of flips for 1 would be 0, and then the number of flip for 0 itself will be equals to 1, right? If we flip 0 to 1, then that would be equals to 1. So the minimum of this, we take the minimum of this, that would eventually be equals to 0. So that is what we'll be doing. So our result will be equals to the minimum of the number of flips for n, flips for 1, or the minimum of the previous result plus the flip of that 0 value. Else what we do is, if we have encountered, it means that we have encountered a value 1. So in that case we are just going to update the value of n, and then finally we will return our result. Let's try to run our code. Cool, let's submit it. So the time complexity of this solution is O of n, because we only have one for loop, right, which is iterating over each of the characters in the string. So that would be the length of the string, and the space complexity is constant because we are only using two variables, which are like integer variables.